Alright, get ready. Because today we're diving into Nvidia's latest research that's nothing short of mind-blowing. Now, if you thought Nvidia was just about GPUs, think again. They're pushing the boundaries of artificial intelligence and robotics to a level that feels almost sci-fi. You're not going to want to miss this, so stick around to find out just how they're changing the future. And hey, if you're excited to learn about the tech that could be in our homes someday, don't forget to like, share, and subscribe. It really helps. So, Nvidia's new project, known as GEAR, that's short for Generalist Embodied Agent Research, is the latest step in creating robots that think and move almost like humans. The idea here is to make these machines not only skilled in one task, but adaptable across multiple tasks, whether in virtual worlds or real life. Imagine a robot that can switch from dancing to picking up objects or even pouring a cup of coffee without breaking a sweat, or rather, without needing a whole new set of instructions. Now, here's where it gets technical, but don't worry, I'm breaking it down. This project is led by some of the brightest minds in the field, Dr. Jim Fan and Professor Yuk Zwa. Their goal? To create a foundation model for these embodied agents, something like the brain that lets them tackle any situation thrown their way. They're developing multimodal models. Think of it as robots learning to see, think, and move all at once by pulling in data from tons of sources, including the vastness of the internet. And here's the kicker. These robots aren't learning through endless trial and error in the real world. Nvidia is using something called Isaac, their ultra-fast, virtual training environment. This isn't your average simulator, though. In fact, what would take a robot a full year to learn in the real world is compressed into just 50 minutes. That's right. In less time than it takes to binge a Netflix episode, these bots are cramming a year's worth of lessons. It's like giving them a time machine for practice, which is just wild. Let me put it this way. If you're trying to master the violin, you might take years. But imagine if you could speed through those years in mere hours. This approach is the secret sauce that's letting these robots advance at lightning speed. Now, let's talk about one of Nvidia's latest marvels, Hover. It sounds like something from a sci-fi movie, but what it's doing is very real. Hover, or the Versatile Neural Whole Body Controller, is Nvidia's answer to a universal brain for robots. Picture this, and normally, a robot needs different control systems for each task. One for walking, another for grabbing objects, another for balancing. It's like if you had to reboot your brain every time you switched from cooking to driving. Not ideal, right? Hover takes all these tasks and rolls them into one. Instead of needing a new brain every time it does something different, it's got a single system coordinating everything. And it's learning by watching us, just like we'd pick up new skills by watching others. Through motion capture technology, Hover is learning human-like actions. So instead of wobbling around or needing constant recalibrations, these robots move like we do, even adapting mid-task. Imagine a personal story here. Like that time I tried to learn a dance routine off YouTube. At first, I was all over the place, needing to stop, rewind, and practice each move separately. But over time, it all came together. That's basically what Nvidia is doing for robots, teaching them step by step until they move seamlessly. Now, a little fun fact to blow your mind. Hover is powered by a relatively small neural network with just 1.5 million parameters. Compared to some of the AI models out there with billions of parameters, this is tiny. Yet, it's achieving remarkable results, like performing tasks that require speed, agility, and complex decision-making. Dr. Fan pointed out that it's all about the efficiency of subconscious processing. When you walk, for example, you don't think about each tiny step. It just happens. Nvidia's Hover aims to recreate that subconscious processing in robots, which is why they're becoming more capable than ever. So, what does this all mean for the future of robotics? Well, instead of specialized robots built for one job, like factory assembly, these machines will be able to tackle a range of tasks. Imagine you're at home, and you've got a robot helper that not only makes you coffee, but can switch to cleaning, organizing, or even helping with your DIY projects, all without any reprogramming. And they won't need constant supervision either. Nvidia's simulation tools make these robots smart enough to adapt to changes and learn from their experiences. And it gets even more exciting. Remember how I said that Hover can perform some tasks better than single-purpose robots? Well, tests show that it can outperform specialist models designed for specific movements. It's like hiring a multi-talented handyman who's great at everything rather than calling in a separate expert for each job. Hover uses something called shared physical knowledge, meaning it takes the fundamental rules it learns about movement and balance and applies them across the board. If you've ever tried something new, like playing a sport or learning an instrument, you probably noticed that skills from one area can sometimes help you in another. The same thing is happening here. Hover isn't just learning individual skills, it's learning principles that apply across all its tasks. At this point, you might be wondering, how do they actually train this robot brain? Nvidia has a pretty cool setup. They start by building a massive data set of human-like movements, everything from walking to balancing to moving arms in specific ways. Then they use an oracle policy. Think of this as the wise teacher model, to show the robot how it should ideally move. Over time, through repeated attempts and feedback, the robot learns to mimic these movements with greater precision. Imagine teaching someone to drive. First, they need to learn basics like steering, braking, and accelerating. But after enough practice, it all becomes muscle memory. Nvidia's setup is similar, where they break down complex movements into smaller pieces and have the robot repeat them until they become second nature. Eventually, this hover policy becomes so fine-tuned that the robot can take these skills and apply them in real-world situations. Now, if all of this isn't mind-blowing enough, check out Nvidia's final trick. These robots don't need any fine-tuning after simulation. They train in the virtual world, and then they're ready to go in the real world right out of the gate. Imagine spending years in a VR driving simulator and then hopping into a real car and driving perfectly. That's basically what Nvidia's robots are doing. They're trained in a virtual environment, and when they step into the real world, it's like they've been doing it for years. To wrap things up, Nvidia's not just making GPUs anymore. They're pushing AI and robotics forward in a way that's hard to wrap your head around. They're creating robots that don't just work like machines, they're starting to move, think, and act more like us. The possibilities are endless. Who knows, in a few years, we might all have robots that make our morning coffee, tidy up our homes, or even walk the dog. If you found this as fascinating as I did, don't forget to hit that like button, share it with your friends, and subscribe so you don't miss out on more deep dives into the future of technology. Thanks for watching, and I'll see you next time.